Solving equations is one of the main things that we learn to do in Algebra 1. And so what we're going to do is we're going to start with solving one-step equations, and we're going to work our way up to solving equations that look pretty complicated, but what we're going to do is we're going to take it a step at a time and simplify them. So first of all, we're going to define an equation. So an equation is a mathematical sentence stating that two expressions are equal. So we have two terms in here that sometimes get misunderstood or mixed up: an equation and an expression. So an equation has an equal sign. An expression is just a phrase. It does not have an equal sign. So equations are sentences, expressions are phrases. So we've worked with expressions before, and now we're going to put those expressions into equations. So we can have an equation 2 plus 3 equals 5. That's an equation that states that two expressions are equal. Now that's a numeric equation because there's only numbers in there. What we're going to talk about now is a conditional equation. Conditional means that it could be true, it could be false. It's conditional. It depends on what we're putting in there. So an equation whose truth depends on the value of the variable is a conditional equation. So this should be separate. So a conditional equation is an equation whose truth depends on the value of the variable. So if I asked, is x plus 4 equals 7 a true sentence? Well, really we don't know, because it depends what we put in for x. So if we put 3 in for x, we would have 3 plus 4 equals 7. Well, then it would be a true sentence or a true equation. But if we put 2 in for x, then it's a false equation. So a conditional equation could be true or it could be false depending on what we put in for it. So this is not equal. It's false. Each number that makes an equation true is called a solution. So when we're looking for a solution, we're looking for a number that makes the equation true. So for this above example, 3 would be the solution of this equation because it is the value or the number that makes that equation true. And then so we're finding the solution. Well, finding the solution is called solving. So to solve an equation, you must find the values that make the equation true. So we're going to see in our directions to solve these equations. So just to let you know, we solve equations and we evaluate expressions. Sometimes we put simplify if they are if they're algebraic expressions. So we solve equations, we evaluate expressions. That's the difference you'll see in directions when you look at those things. So looking at the top here, how would you solve these? You have x minus 7 equals negative 35. So you would want to find the value of x that makes that true. There's a couple different ways to solve it. We could think through it and think, okay, I already have a negative 17 because that's like plus a negative. How do I get a negative 35? So what plus negative 17 equals negative 35? And we could figure that out. It would be negative 18. The next one's even easier. You could think x plus 10 equals 142. What plus 10 equals 142? Well, that would be 132. What divided by 5 equals 21? You could figure that out. This one's pretty simple. 3 times what number gives you 9? So you have all those different things, and we could think through them. But what we're going to do, and what's nice about algebra, is you can come up with a procedure or use some rules to help us get there pretty much the same way each time. But please don't forget, in stuff like this, you can figure that out in your head. That's 3 times what equals 9? Well, we know 3 times 3 equals 9. So I don't want you to forget some of your common sense stuff, but we are going to learn some of this new stuff, so when we get harder equations that aren't easy to do in our head, we can work through them step by step. An inverse operation is the operation that will reverse or undo a given operation. And we've talked about inverses before. The inverse of, for addition, like if we had 7, we're thinking what plus 7 gives us 0? Well, the inverse would be plus a negative 7. We also have inverse for multiplication. The inverse of multiplication oops, 3 times what gives me 1. The identity for multiplication, 1/3. Well, multiplying times that's kind of that's the same as dividing 3 divided by 3. So we can think addition and subtraction are inverses, multiplication and division are inverses. Equivalent equations have the same solution. So really the idea behind this, and not as much in this one because these are really just one-step things, but the idea behind it is that we're going to do things to our equation that will make other equations that are equivalent, and those equations will have the same solution. Couple properties of equality. And when we look at these, really 2 properties of equality, it's almost 4 properties of equality if you look at it a different way. So if you have two things that are equal, this has a equals b, but realize that a could be some expression like 7 plus 10. A could be 7 plus 10. There, a equals b and c is a real number, then you can add c to both sides. So the way that we would say that in easier words, you can add the same thing to both sides of an equation. Also, because addition and subtraction are related, you could subtract the same number from both sides. The next one, multiplication property, you can multiply any equation by the same number, and it will still be true. Same thing with division. You just cannot divide by 0, so you can divide both sides of an equation by the same thing. So if you think of an equation as a balance, so one thing equals another. So an equation is like a balance. That's like a seesaw. So if there's different weights on a seesaw, if I double this weight, what do I have to do over to the right side to double it or to keep it balanced? Well, you would also have to double it. So this is times 2. That's what I'm writing there. So you would have to double it also. So an equation is like a balance. So if we added 15 pounds to this side, what would we have to do to the right side to keep it balanced? We would have to add 15 pounds to that side. Or if we took off 80 pounds, if we took off 80 pounds from this side, we'd have to take 80 pounds off from this side to keep it balanced. So an equation is like a balance. What we do to one side of the equation, we must do to the other side of the equation. So to solve an equation, find what's happening to the variable. Is something being added to the variable? Is something being subtracted? Is something being multiplied? Is something being divided? Or is the variable being divided? So figure out what's happening to the variable and then do the inverse operation to both sides. Now this one, example 1, could be a common sense one. You could think, what number, if you subtract 12 from it, would you get 15? And hopefully if you think through that, you would realize that it's 27. That's not always going to be so simple, so we want to learn this process. So we're thinking, find out what's happening to the variable. So here's the variable, what's happening to it? Well, 12 is being subtracted from it. So if 12 is being subtracted from it, we are going to do the inverse of subtraction. So the inverse of subtraction is addition. So we're going to add 12 to both sides of this equation. And I like to put it vertically, like underneath it. So, but really we're thinking this, we're combining this. So these are on the sides of our equation. So I'm going to add 12 to both sides. I chose 12 because I know that a negative 12 plus 12 is 0. So now I have x plus 0, which is just x. And on the right side, I have 15 plus 12, which is 27. So I determined what's happening to the variable, and then I did the inverse operation to both sides. So we mentioned that one would be 27 earlier. For this next one, this one is not as straightforward. We might not be able to think of the fraction that you have to add 2/3 to get negative 7/12. So this is where our steps help us. So we determine what's happening to our variable. Our variable here is x. What's happening to it? Well, 2/3 is being added to x. So what we do is we do the inverse operation to both sides. So 2/3 is being added to our variable, so we're going to subtract 2/3 from our variable. And what we do to one side, we have to do to the other side, because an equation's like a balance. Now on the left side, this is nice and easy because we have x plus 2/3 minus 2/3. We knew that these two are just going to be 0 because they're inverses or opposites of each other. So on the left, we're left with x. On the right, we want to do negative 7/12 minus 2/3. Well, we can't right away do that problem because we don't have common denominators. So we're going to find or get a common denominator. Common denominator of 12 and 3 is just 12. So we'll multiply this by 4/4. And so we're going to have x equals negative 7/12 minus 8/12, because 2 times 4 is 8, 3 times 4 is 12. And now we can answer this. So negative 15/12, which does reduce. 3 goes into this 4 times, 3 goes into this 5 times. And so we have negative 5/4 as our answer. So again, all we did, find what's happening to the variable, do the inverse operation to both sides. So that's what we did here. The rest was just using what we learned before. We know 2/3 plus negative 2/3 is 0. And over here, we're adding fractions or combining fractions, and we know how to do that. And we know that we have to get a common denominator and add those. Or in this case, subtract. Looking at the next one. Example 3, what's happening to the variable? Well, the variable is being divided by x. It's being divided by 7. So we're going to do the inverse operation. I'm going to give ourselves a little more room here. We're going to do the inverse operation, which the inverse of dividing is multiplying. And so the way that we can write this is we're going to multiply both sides by 7, because what we do to one side, we have to do to the other side. Now on the left, we chose to multiply by 7, so they should undo each other, but let's show why it works. When we multiplied by 7, that's the same as 7/1, and now we can reduce, or put in lowest terms. 7 goes into 7 once, and we're just left with x over here. And that's what we should be left with. That's why we chose to multiply by 7. So we found what's happening to the variable. It was being divided by 7. So we did the inverse, because the inverse of division is multiplication, and we multiplied both sides by 7. Over here, negative 13 times 7, a negative times a positive is negative, and 13 times 7 is 91. Look at example 4 here. We're again thinking what's happening to the variable. And we see the variable is being multiplied times x. And so we think, well, what's the inverse of multiplication? That's division. So we're going to divide both sides by 3. On the left side, 3x divided by 3, we know that reduces. And so we're just left with an x. On the right side, we have 99 divided by 3. Some of you might recognize that reduces, or you might have to do the division problem. 3 into 99, that's 3. 3 times 3 is 9. So 33. We're going to do a couple more examples. Here's a few more steps, or written a different way. Determine the operation performed on the variable. So that the way we wrote that before is what's happening to the variable. Is something being added? Is something being subtracted or multiplied? Then do the inverse operation to both sides. Simplify it. So we saw that a couple slides ago when we did this one. We really had to simplify this right side. That took us a little time. Over here, we had to simplify this. And then check your answer. Well, we haven't done that yet. Remember, what we're doing is we're solving these. So let's go back and let's just pick one to check the answer. Let's come look at example 3. And we want to check this answer. The way that we check the answer is we want to see if this is correct. So we go ahead, take our equation, and we solved and saw that x should be negative 91. So we're going to put that back in for x. So negative 91, because that's x right there. Negative 91 divided by 7 equals negative 13. And we want to see if that's correct. Well, we're going to go 7 into 91. That is once. Bring down the 1, we get 3. And this was a negative divided by a positive. So that's negative 13 does equal negative 13. So we were correct. And that's how you check your solution. You plug your answer in to see if it was right. We could do the same thing here really easily. 3x equals 99. We solved and we said, well, we think that x is 33. 3 times 33, well, it works. 99 does, in fact, equal 99. Looking here, it says justify each step in the solution of the equation. So we're going to go ahead and start with this equation. This just gets us to think through why we're doing what we're doing. So what we usually do is we write something in there and we state why we know it's true. Now, how do I know this original equation is true? Because that's the equation I started with. That was given to us, so that was given information. So what would we do here? Well, we're thinking through this. Determine the operation performed on the variable. So what's happening to the variable? 2/9 is being subtracted from the variable. So we're going to do the inverse operation. We would since it's being subtracted, we're going to add 2/9 to both sides. And justifying each solution, why can we add 2/9 to both sides? Well, we can do that because of the property we talked about earlier. That's the addition property of equality, which states that we can add the same thing to both sides. So the addition property of equality. This you may not have thought about before, but we'll write the next step over here on the left side. And I'm going to write in a step that we might not normally write in. I'm going to put x plus 0 because this is 0. Now what property do we use? So looking back or thinking back to chapter 1, we learned some properties and we have negative 2/9 plus 2/9 is 0. Well, that's the inverse. Remember that? The inverse property tells us that something plus its opposite is 0. So this is the inverse property of addition. That's for this step. And then over here, we have 5/3 plus 2/9. We can't combine those yet. We'll go ahead and get a common denominator. So now we're just simplifying. So we don't necessarily have to justify these steps. This is just our arithmetic. But we have multiplied by 3/3. Actually, we could justify this. We're multiplying by 3/3, and we can realize 3/3 is just equal to 1. So this is 15/9 plus 2/9. So why can we multiply something by 1? 3/3 is just 1. It's a form of 1. So multiplying by 1, well, that's the identity property. Because if we multiply something by 1, we get the same value. And this is the identity property of multiplication. Because we've learned that if you multiply by 1, which 3/3 is 1, you get the same value. And now 15/9 plus 2/9, 17/9. And that is just addition. We added those together. So we justified each step. So it should be, you should understand or see, because we've talked about these different things. Now this is new because we haven't really said that's given information. We've talked about the addition property of equality in this lesson. We learned about inverse and identity earlier, and now you get to see where we use those and how they're used. We don't always end up writing these out, but at least you know why we do them. Okay, the next one is called a literal equation. There's no numeric values in here, there's variables. It says solve x plus m equals n for x. So we want to solve for x. That's our main variable. So determine the operation be performed on the variable. Well, there's on the variable. There's all variables here, but our main one here is x. So what is happening to x? Well, we see that m is being added to it. So we want to do the inverse of adding, and so we would subtract m from both sides. Over here, m and a negative m is 0, so we have x equals. And over here we have n minus m. Those are not like terms, so therefore we can't add them, and so we leave it as is. So x equals n minus m. Our last example here has to do with more of an application. This is from the laws of thermodynamics. His first law states that force of an object is equal to its mass and multiplied times its acceleration. So force equals mass times acceleration. Solve the formula for A. So this is really saying A is our main variable. So we have force equals mass times acceleration. What's happening? Determine the operation performed on the main variable. Well, m is being multiplied times our main variable. So how do we undo, or what's the inverse of multiplication? Well, it's division. So we would divide both sides by m. And we know m divided by m reduces, that's just 1. And so we're left with f over m equals a. We could rewrite this. We haven't talked much about this, but we can always switch equations. If f divided by m equals a, we can say a equals f divided by m. That's called the symmetric property when you switch the equation around like that.